Hey everyone, today I want to cover the magic of muxes. Muxes stand for multiplexers, and really all it is you give it a set of inputs and it chooses one of them. It's basically saying, it's sort of like saying like, if S equals to 0, then select line 0. And that's really all there is to muxes. If you give it a certain input on your select line, you're going to actually select that specific line and have it output whatever value is on that line. So, how do we usually draw muxes? They just kind of look like this. And we'll have a series of select lines. I'm just going to put an N to show that we have multiple select lines. And then we're going to have a set of inputs. And this will be like A, B, and so on. All the way up until you have your final value. And there's usually 2 to the N inputs for N select lines. And the reason for that is, if you think about selection, we just have, if we have 0 and 1, we have to have a power of 2 for our N selection. And that's just, we've got 2 options for 0 and 1. We have 4 options for 2 bits, 8 options for 3 bits. And let me just show you. Let me show you. That'll be a little bit easier. So, let's do the simplest form over here. We've got a 2-input mux. I'm going to put A and B for our inputs, and we'll have a single select line. And then, of course, I forgot to put our single output. Single output over here. We want to basically pick between A or B to go on our output Y. So how will we do that? And really, all this is going to do is, if S is 0, then Y is equal to A. And then S of 1, then B. Y is going to be equal to B. So let me go ahead and draw that out over here. So I'm going to say S equals to 0, Y equals to A. S equals to 1, then Y equals to B. Whatever A and B might be. So if A is 1, then Y is equal to 1. If A is 0, then Y equals 0. It's really just taking this line and kind of like connecting it over here, and this line and kind of connecting it over here. So that's really all there is to a mux. It's selecting between our set of inputs. So what if we want to have 4 inputs to select from? So we need to have 2 bits of select. Here, let me change back on my black pen. I am so bad at drawing today. 0, 0, 0, 1, 1, 0, and 1, 1 for our selections. So A, B, C, and D. And then, of course, we have to have our 2 select lines, S of 1 and S of 0, to be able to select these things. And then we have our output Y. So let's go ahead and write a truth table for both of these things. I'm just going to say, instead of doing a truth table, I'm going to call this like a path table or something. So I'm just going to say S and then Y for our output. So if S is 0, we pick A. If S is 1, we pick B. And likewise over here, we've got S1, S0, and Y. 0, 0, 1, 0, 1, 0, 1, 1. If this is 0, we'll pick A. Otherwise B, C, or D. Whatever that may be. So if A happens to be 1, then Y is going to be 1. If A happens to be 0, then Y is 0 if we picked on A. And so on. So really, we're just going to pick these lines. Again, it's nothing crazy, but suppose, let's go one step further. Now let's start to get a little bit crazy. Suppose we want to take a 4-input mux, and we want to make it from 2-input muxes. How would we do that? All we're doing is we're selecting these lines, so let's go ahead and say, let's do something like this. We have our 0 and 1 for this, and I can just go ahead and put A and B, and then I'll set this to S0, and then we have another one over here, which is going to be our C or D, 0 and 1, and again S0. And all I'm doing here is I'm looking at these chunks. So we've got our S sub 0 for that one, and we got our S sub 0 of 1. And then all it's going to do is, okay, if I get a 0, I'll output A over here on this line. And on this one, I'll output C if S0 is that. Now we can just feed these into another 2-input mux. Man, I really suck at this today. So 0 and 1. And this will be our S1 input. So if S is 0, we'll pick whatever's the output of this mux. And if S is 1, we'll pick whatever's the output of this mux down here. And, I mean, simple enough, right? So this will go to its output. So suppose we get 0 and 0. Well, A is going to be asserted here, and then A is going to be asserted here. If we pick 1, 0, for instance, so S1 is going to be a 1, and S0 is 0. This is going to pick this line, and then S0 is going to put C on it. So C is going to come and propagate through here. So the output would be C. And that's really all there is to muxes. The only other cases that might show up and be a little bit weird is suppose we only have a 3-input mux. 1, 2, and then 3 for our select lines over here. So 0, I'm just going to write it like this for now. How many inputs do we need, how many select lines do we need for this to make sense? Well, there's no way that we can select 3 things with just a 1 input. We actually have to do the closest 2 input, or the closest power of, or log base 2 of n of whatever this n input is. So if we have 3 inputs here, if this is 2 to the n inputs, normally goes to n select lines, then we can get this number of select lines. I'll call it S is equal to the log base 2 of number of inputs, and then we have to do one extra thing over here, and that's the ceiling function. And all it's going to do is it's going to say round it up to the next integer, the next biggest integer. So if we have 3 inputs, the closest thing that we can get is, like if we do the log 2 of n, the next closest to 3 inputs is 2 bits select. And suppose we have 15 inputs, or 12 inputs. Well, we know our powers of 2. We get 2 to the 0 equals 1, 2 to the 1 equals 2, 2 to the 3, 2 to the 2 equals 4, 2 to the 3 equals 8, 2 to the 4 equals to 16. Well, what's the closest one to this, to these two numbers that's available? Well, that's 16. So it means that we have to have, let me go ahead and pick another color really fast. We have to have our 4 go to 4 select lines to be able to pick between all those numbers. And that's really, that is the only real corner case of these muxes, is having to know this equation here. Oh man, I cannot see that blue. Okay, this equation. So, those are muxes in a nutshell. Let me know if you guys have any trouble with them.